outlet, receptacle, plug? Which is it? Alright guys, today we're going to talk about receptacles, outlets, plugs. What are they really called? And we're going to talk about the 5 biggest tips that you may not known about outlets or receptacles. Now I've watched a lot of videos on YouTube, being professional, they all have a lot of great tips, but we're going to try to provide a few that you may not have known. So the first thing we're going to do is start talking about the receptacles themselves. These little guys here, we have a black one, and an ivory one, and we have a decor one. They are actually called a receptacle. In the code, and now I may get grilled for this because we're in Canada, so we go by the Canadian Electrical Code, but I want to see your comments down below from you American guys, what you actually call them. I'm pretty sure you call them a receptacle as well, but we call them a receptacle here in Canada. So receptacles is in our code, and that's how we go by. However, the slang term, or the term that we use out in the field, is outlet or plug. So you'll hear a lot of people say, I want a plug put in, or I want an outlet put in. First biggest thing that you may or may not have known is that these are called receptacles. They're not outlets. Outlets in our code are outlined as a power point that you can extract power from. So for example, and this is a bit of a gray area, an electrical socket. Oh, there's another name for it, socket too. That's another slang term. So an electrical outlet or receptacle, we keep calling it outlet, receptacle is one. In our code it states that we can only run up to 12 of these on a circuit. However, this is an octagon box. So if you have a light fixture that hooks up to this octagon box, technically here in Canada, we're supposed to count these. Now they let us get away with smoke detectors, we don't count those, and of course we don't count switches. But if you have a number of lights on a circuit, they consider these technically outlets for wiring methods in section 12 of our code. So when we're counting up our 12, we don't want to include these because it reduces the amount of receptacles that we can put on a circuit, and of course we have to put the circuit on an arc fault. We all know that arc faults are expensive, so we want to minimize that as much as we possibly can. So you can see here that these outlets, we have residential grade, and we have a little higher grade quality here. Oh, no we don't. Hang on a second. Okay, got one. So this is a residential grade. You've all seen it. Cheap version. This is commercial grade. It's actually a 20 ampere. So the difference is which is the second thing, which we talk about the J hooks and making the hook on the back of the wire, or inserting it right into the terminals in the back of the outlet itself. Now, on the residential grade, the standard J-hook is the most common. When we put the J-hook on, we always put the J-hook in a clockwise motion so that it faces over there, and we hook it on and then thoroughly tighten it down. Now, we can put up to 2 of these on a receptacle, so we can come into the box with a wire or a piece of 14-2, and then we can come out of the box with a piece of 14-2. We don't use the back of these quick connects simply because they don't make good contact. And anything under a load or a larger load that's plugged in will cause heat. And where there's not much contact on the back, in the back of these when you push them in, heat obviously causes arcing, and arcing causes fire. And unfortunately, breakers are made to detect overcurrent or a short circuit condition. They're not made to detect a slow heating from arcing, which will happen with a loose connection, which is exactly what happens inside of these. And we have more than 2 wires, a 14-2 coming in and a 14-2 going out. We usually do pigtails, so we'll put the 3 wires together and then a tail off and go to the receptacle, instead of trying to jam, 2 of the wires under these and then shove one in the back. That's just not practical at all, and it's not a good practice. Now the commercial grade, however, is a little different. So the commercial grade, let me straighten this out here. The commercial grade goes right in the back, and these have plates that actually tighten together when we tighten the screw down. So it actually makes a good firm connection onto the receptacle. But in no means do we still drive a bunch of wires in the back of these. We'll usually just put 2 as a rule of thumb, and then if we have any more than that, we'll do, of course, a pigtail. So we don't stick 4 wires in the back of these. It's just not healthy because there's too many connections in the back of the receptacle, even if it is a commercial grade. So we try to avoid that at all possibilities. So the third thing you may not have known about a receptacle is, of course, tamper-proof. So we have tamper-proof model, which everybody hates. These receptacles, they're all tamper-proof except for this one. So we have tamper-proof receptacles. So these little plastic tabs in here prevent children, that's what tamper-proof is for, so it prevents children from sticking forks or anything that may cause them to get inside the receptacle and cause themselves to get electrocuted. So this not only goes for children, but it goes for elderly people and of course me and everybody else, because it's extremely frustrating to try to plug something into these unless you're straight onto the receptacle and you're plugging it in firmly. Other than that, if you're off a little bit of an angle, you're not getting that in there. So this actually came out, I think it was 2018, correct me if I'm wrong, in our code. I'm curious as to when it came out in the US code, but there are exceptions to these tamper-proof receptacles. So it states that we must have tamper-proof receptacles in any dwelling unit with sleeping quarters. So that means a house. That does not mean a garage. So in a garage, we can still use non-tamper receptacles or shed or any type of outbuilding. So we usually do in that situation because they're easier to use, to be honest with you, than the tamper-proof receptacles. It's one of those things that we get calls for all the time. People are very frustrated because they just can't simply plug something in because they're not straight onto it. So the fourth thing that we're going to talk about is receptacle up or down. There's nothing in our code that states that a receptacle must be up or down. It is really preference to the job specifications. The industry standard is ground down in residential use. The industry standard in commercial is sometimes ground down and sometimes ground up, depending on the specs, usually the engineered specs for the job project itself. Now in hospitals, it's usually ground up. And this is one of the things you may not have known. The reason that they put the ground up, or they put the receptacle upside down, as we call it, is if something is dropped onto that's half plugged in, then it hits the ground first instead of the live conductor or the live plugged in device, and then won't cause a shock or an arc or a short circuit. So it's just a safety standard that they go a little bit above and beyond that they make us do, and we usually see it on commercial projects or sometimes even seniors' homes. We'll do that with the ground up. Now, we can also mount the receptacle sideways. Now, a lot of people have these in their homes. A lot of people will have them underneath their kitchen counters. If they're limited for space, you'll see the receptacle get mounted sideways. So I wanted to just talk about that for a minute because there's different ways to do that. Now, I see a lot of electricians, they'll just slap it on with the or the live conductor or the live side of the receptacle up in the air, which is questionable. Sometimes it's not a good practice for us. Whenever we install them with the neutral up. And really it depends on the location. So for example, if you have one on the side of your counter, we always put with the neutral up, facing sideways, so the ground would be to your left. And that's so that if you go to plug something in and of course something drops on it, like a kitchen utensil, then you won't get that arcing or you won't get that electrocution. However, that's not always practical in an outside outlet. So if we stick an outside outlet in this way and there's a cover on it for waterproof protection, and you reach up, depending on which way the cover opens, and you reach up, sometimes if it's not plugged in all the way, you'll get your index finger onto that live conductor. So often we will stick the receptacle either up, if we can mount it that way, or sometimes we'll stick the hot side up because it opens on the bottom, so we don't want anybody to get electrocuted. It's just a safety precaution that we do. So with the GFI, it's the same thing. So we'll stick usually the neutral up if we can, preferably. That's sort of the industry standard. But there are times, depending on the cover, which we will put the hot up. And a lot of these new in-use covers, or heavy-duty covers that we use here in Canada, open sideways or up and down. So that usually leaves us in a situation where we have to put the hot up. It's just not practical. And finally, the fifth one that you may not have known about is the ears on these boxes. Sorry, the ears on these receptacles. So the ears on these receptacles are removable. You see that? A lot of people use them for different reasons, but we tend to use them for rework. So we tend to use them in situations where we get into a rework box that has ears that goes in the wall, or under a cabinet, or in a counter, or if you're cutting into MDF or cabinetry. So what happens is when you cut this box in, these ears here set against the finished product or the finished wood. So we'll need to stick screws in these, usually number 6 screws or number 4 screws, Robinson, to recess it. If you then go and you put the receptacle in place, let me see one here without a screw. If you then go and put the receptacle in place into the box, sometimes the screws that we put in to hold the box in place, focus, not focusing, there we go. Sometimes when we go to put the screws in, it will hold the actual receptacle out off the wall. And then when we go to put the plate on, the plate sticks off too, and it looks like crap. It really does. So what we do in a situation like that, we will break the ears off of the receptacle. Then when it gets inserted into the box, focus, there we go. When it gets inserted into the box, it leaves room on either side for those 2 screws to go in, and still the screw in the center, and then it gives us a nice flat surface to put that finish plate on. And last but not least, one of the things that you probably didn't know, Eaton makes an outlet with a quick connect. So on this receptacle, you can see here, it says quick thread right on it. Actually, sorry, this isn't made by Eaton, it's made by Hubbell. And I think Hubbell is the only one that does this. So if we take our plate, big time saver, and you have your receptacle in the wall, you just stick your plate on and you push it. That's it. You don't need to tighten down any screws. Of course, we try to line the screws up, but you don't need to do any of that. It just snaps right in place. So it's a lot quicker for us. So that's something that you probably didn't know. And they don't come off easy either. You have to unscrew them, so it's only a one-way connection when you push it in there. So that's something you probably didn't know about the particular brand name, and I think that's a patent that that Hubbell actually has. So that's it for today's video. Thanks for sticking around and watch it. Don't forget to like and subscribe. Remember, these videos are made in Canada, and never do your own electrical work. Always consult your own local licensed electrician, and we'll see you next time.